this is the advantage of having a basic science lab and infrastructure and seeing patients and knowing colleagues. I mean, there's literally tens of examples per year, where we see something in the clinic and then we take that material, to the lab, try to figure out what's happening, and vice versa. We see something in mice and we rapidly validate when we see it in patients. So this is happening all the time, and this is also fun. This is the fun part of being a physician scientist.
Welcome to Called to Science, where we uncover the untold stories of the people pushing the boundaries of the life sciences. In this episode, we talk about blending the worlds of science and medicine, what's at the heart of being a scientist, and how fly fishing and research are really not so different. Welcome, Bart Lambrecht.
Hi.
You're the director of the VIB Center for Inflammation Research and are considered a world authority on asthma and allergy. You're also a medical doctor working with patients and even worked full-time in the hospital throughout the COVID pandemic. You've received several awards for your research, including one of the oldest and most prestigious Belgium has to offer, the Franqui Prize. This award-winning research has led to pioneering insights on the origins of allergy and asthma, and advanced our understanding about how excessive hygiene and lack of exposure to infections leads to a misalignment of the immune system. This revelation paved the way for advances in the treatment and prevention of asthma. Bart, welcome.
My pleasure.
So, as I kind of mentioned in that intro, you have a very interesting career that bridges these two worlds, working in the hospital, working with patients, and also doing fundamental basic research. Before we dig into that, I have to ask you, because I read in some of the notes that they gave me, you're into fly fishing. Is this a new hobby or something you've done for a while?
No, it's something I've done since I was a kid.
Oh, okay.
So, but you have to think of this, I live in Flanders, so there's no fly fishing
was my next question.
No opportunities. So for a very long time, I was dreaming about fly fishing, trying it out in ponds where there was virtually no fish to catch. But I persisted, and part of the hobby of fly fishing is also tying flies, making your own flies. Mm-hmm. So that kept me busy for about maybe the first 10 years, But then actually through my scientific career, I started visiting, a lot of countries like the US, Canada, Australia, where there's plenty of opportunities. So this hobby really kicked off in real time when I became a scientist. So I basically every meeting I go to, I try to chip in an extra day of fly fishing.
Yeah, so you're just always traveling with the rod, with your box of flies.
People think I'm carrying a poster, but it's actually fly rods.
Right. So I mean, because I grew up Calgary, Alberta, Canada, and we're at least what we're told. One of those pride things that we have of our little areas that is some of the best fly fishing in the world, right at the base of the Rocky Mountains. So I've never done it, but I grew up watching it, right? And knowing, family members, people that, they get so into tying these flies. It's like a very meticulous, also kind of creative hobby. And to me, the whole thing seemed rather like meditative. You're out there by yourself, this casting motion, or even tying the flies. Is that kind of what you get out of it, or?
Yeah, it's a technical hobby. It's not like regular fishing, where you're sitting.
That's too easy, right?
Aside a pond. Yeah, it's also nice, but fly fishing, it's difficult. It requires some skills, some technical expertise. But it's indeed very meditative. So once you're at the river, you forget about everything. You just focus on the stream. You try to figure out what's happening. It's also a little bit about insect life. Trying to figure out which insects are on the rise, which insects are hatching. And then you have to match that hatch, it's called in fly fishing. So you have to figure out what are the insects and then look in your fly box if you have anything that looks like it, and then hope that you can fool these fish, and to taking your fly. So it's very nice to do that. But it can also be very innervating, if they're not biting, So this is actually also something you need as a scientist. You have to handle frustration, right? So, I mean, if your paper is if your paper is rejected, it's like a fish not biting. You have to handle the frustration, and move on and try to figure out a solution.
And rather than flies, you're always trying to find the topic, right? That the publishers, that the journals want to know about. So
or you try to find, the right journal, right? Which
right,
is
exactly.
Like choosing a river. Where do you want to fish?
Exactly. Well, I got a lot more detail about fly fishing because, like I said, I just watched it from afar. But we could probably spend a whole episode talking about the similarities between science and fly fishing here. But we'll move on to your origin story in research and science and medicine, because you've kind of come full circle. Born in Ghent, left to do studies, which is very common for academics. But then you came back to Ghent. Did you always know that you wanted to come back, or was it opportunities presenting itself?
Yeah, the opportunity presented. So I was actually very happy in the Netherlands. So I worked in an Erasmus University in Rotterdam for 10 years, and that was a great opportunity. So I was very young when I moved there. I was just, finished my PhD, still had to finish my specialty training in pulmonary medicine. But the professor there, Henk Hoogsteden, who I really consider also as my mentor, Henk really gave me a lot of opportunities while still in specialty training. So that's very unexpected, and it's something I had hoped for here in Ghent, but they couldn't give it here, in Ghent. So I moved to the Netherlands. I was very happy there. I was very loyal to that department. I planned to take my entire career to do that in the Netherlands. But then there was this very great initiative from the Flemish government, where they're trying to pull back people, from abroad who have been abroad for a couple of years, and they really made an offer I couldn't refuse. Even at current day standard, this is like almost 20 years ago, but even at current standards, these are still the biggest grants you could get. They're called the Odysseus grants. Was an initiative of the Flemish government, and there was really no way I could say no to this. So the main reason why I said yes is the opportunity, and also I knew how well trained scientists are in Belgium. I had been a couple of places around, so I knew I could do something with that money. And also with the grant that I got, it allowed me to move part of my team from the net. So I could take like a kickoff, a flying start, and those were the arguments, why I decided to still leave Rotterdam. But in the first years were hard, I must tell you. Rotterdam, I really missed it. It was a very collaborative spirit, a lot of critical mass together, and I really learned my job very well in the Netherlands.
We've talked about it a little bit now, again in the intro and whatnot, but these two disciplines that you have, medical doctor and fundamental researcher. I'm curious, how that developed. Like, what came first? Was it an interest in biology, or wanting to be a doctor first, and then being introduced to things along the way?
It grew organically, I would say. I was doing my first year of specialty training, so internal medicine. So that's very general. I had to work really hard. I'm old style training, Basically on Monday morning, we were going into hospital, and we were allowed to leave the hospital the next week on Monday evening.
Whoa.
So that's a full more than 7 days of working and on call, and I did that 1 and 2 and with no recovery time. So the Tuesday after, you had to work again. So there was no recovery, So this allowed me to really learn a lot in my first year of medical training. I had a super good supervisor, somebody I absolutely admired. His name was Marc Cardon. He was like my idol in medicine. I thought he was the best doctor I've ever seen. I learned everything from him. But in the last months of my training there, I asked him about his career, and he actually said, if there's one thing I could do different in my career, I would do research, he said. And this came completely out of the blue for me, because I thought, the way that you become a good medical doctor, is by seeing patients. The more patients you see, the better doctor you become. That was always my view, if you will.
Makes sense, yeah.
But this guy, who was such a good clinician, told me, if there's one thing I can do, this would be it. So that made me turn my interest into science. And since I had seen so many patients, in a very short, and I also did a lot of procedures in that first year, I actually also figured out, is this really what I want to do for the rest of my life? See all those patients. You can do something for the individual patient. And it's very gratifying as a doctor, to see a result, to cure somebody, to get mainly, the gratitude of the patients when you do that, but there's more to medicine than just seeing patients, And I always had a spark, as a medical student. I always learned more than actually what was in the course. I was always triggered to learn about, medicine, and I was, in addition to our curriculum, I always read, like English textbooks, more on pathophysiology, and I took that along. So I always had this interest in mechanisms of disease. And that's what was my main call to science, I would say. Driven by the clinic, to understand disease better.
Yeah. Interesting. You kind of preempted some of the things that I was going to ask, because I think what you said there about you can do something for the individual when you're a doctor. You see them, you alleviate symptoms, you give them some kind of treatment, right? But there's that whole background that has to come in order to develop those treatments, right? Or to build that understanding of how you can then help patients. And that comes from fundamental research, which is really interesting to me. So yeah, it's just that, how do you find those two motivations then work together?
Right. So you're absolutely right that fundamental research is at the basis of discovery. But what I've come to realize over my career, now, like almost 30 years in science and in translational science, is that it takes also much more than a basic science discovery, right? So being a doctor on one spectrum, on one end of the spectrum, and then a basic science on the other one, there's this giant gap in between, And over the years, we made a couple of basic science discoveries, which I thought were really nice, but to make that, to turn that into a reality, you have to be in the right environment. You have to have the right connections. And what I have learned is by working with biotech, you can learn enormously, how to take your invention, your basic science invention, to the clinic. This is a giant step that doctors don't understand and basic scientists don't understand. You really need a special breed of physician scientists, and even physician scientists who are more leaning towards the basic science to facilitate that transition. And that's something that I've only learned recently, the last 10 years, I would say, how much it actually takes, from a basic science discovery to a first-in-man trial, to a trial where you can say, okay, this is a patient being treated with your idea. It's very gratifying again, but it's a huge, huge effort and involving many, many people, many disciplines, many expertises. And being at VIB, is one of the strengths of VIB is that they make this possible. That I'm very happy now. I mean, I used to miss Rotterdam, but since I'm at VIB and Ghent, I really love it here now.
So now we have a segment called Dare to Ask, and this is questions from the VIB community. They've been submitted, and they're things that people might have wanted to ask you but never dared to ask. So we're gonna do that now. Are you ready?
Yeah.
So first one. Often the road to becoming a PI is very long. Would you do it again?
I would do it again.
Yeah. What exactly, if you could say specifically, what was especially worth it for you about that journey?
Well, for me, it's the idea that you can work together with a team, and lead that team into discovery, but also seeing people grow. I mean, I was mentioning already a medic coming into your lab, having no experience in science, often very scared of what's going to happen. Taking them through those early months, motivating them, and then seeing them become independent, seeing them doing their own first experiments, that to me is very, very gratifying. And also being a PI, having that responsibility, I actually kind of like that. There's a bit of a business angle to being a PI. You have to manage your funds, you have to make sure that everything keeps on running. That business aspect has always, been interesting to me.
Mm-hmm. All right, here's another one. In your career, what do you get the most satisfaction from? Is it, publishing papers, doing conferences, your students graduating? What is it that you really enjoy?
I actually enjoy the writing. When I see like an unfinished text, and I see like data, I always think, how we're going to write this up. I really love writing. I love to write reviews. It's a lot of work, but summarizing literature and then actually helping your colleagues, that is also quite rewarding. So since I'm a basic scientist, I can write about asthma, about progress in, immunology of asthma or other aspects of asthma, but I can translate it to a level, that doctors can understand. So when I write a basic science article, even for journals like, Nature Immunology or Immunity or something, it's always meant for basic scientists, but I write it actually for doctors. And that's why I think they're cited a lot, those articles, because they're understandable.
Right.
I've often learned, in medical school, if you talk to a patient, you have to be at the level of a 12 to 14-year-old. You can't make it too difficult. But I think also in medical writing, we should really try to make it understandable. Right. And, that's something I'm always trying to do in my papers.
A bit out of the box, let's say. What's the most unscientific belief you hold, maybe secretly, and why?
Unscientific belief. Well, I believe that, that having, a firm family, a good relationship is really important. Also as a scientist, if your wife supports you, if your children, respect you, I think that's really important to have.
So the unquantifiable power of love.
Unquantifiable power of love and family.
This was Dare to Ask. If you have a question you've always wanted to ask, put it in the comments or ask anonymously via the link in the description. We make this podcast to highlight the people behind the science. If you enjoyed it, we'd love it if you left a review or shared it with someone you think would like it too. I want to ask then about sort of more, let's get to the fundamental research part, your sort of research interests, even your clinical interests, looking at the lungs and your career, you kind of get labeled as asthma, allergy. But was it really about the disease, or was it about the immune system, or the like what drew you into that world?
What drew me into it is chance, honestly. So I wanted to learn more about disease. So I thought I would do medical genetics. That was my first idea, and I was mainly interested in kidney disease. That was my first idea when I started doing science, thinking about science. So I approached the internal medicine, supervisor, telling this, I want to change my path, from second year training. I would love to do a lab work in medical genetics. So this professor, his name was Romain Pauwels, very famous in asthma. He said, well, it's too early. Maybe you should come to my lab, and then we can see what you can do there, and this got me into pulmonary medicine. This was not intentional, but then I was in it. And, the topic we chose was, something totally new at the time, the role of dendritic cells, which are a special form of immune cell. It's recognizing dangers in the immune system. He had never worked on it. He had no immunology experience, this professor. So basically I got kind of carte blanche to set up immunology in a lung department, which was in a way horrifying. It's like dropping a medical guy, into a lab with no experience, and also the lab having no experience, to do that topic.
And so, immunology is one of the really complex topics in the body.
But thank God, we had a very good basic immunology department at Ghent University. So I literally, spent my first months training in immunology in another department. And the next big thing that changed me a lot is, so this professor had a grant, from a donation grant from Flemish Television. To buy equipment, and he basically told me, we can buy equipment. What do you want to buy? So I said, I want to buy a flow cytometry sorter, which even now, when I have to buy one with our department, this is a big investment.
Right, yeah.
So you have to think of it. I mean, me, this medical guy with no clue, 3 months into
Give me the most expensive machine, yeah.
3 months, into my training, I had to go to, BD to Bactron, but to Coulter, these providers. So that brought me into contact, with negotiations, trading, because I was sitting on this pot of money, which by current standards would be something like €1 million, and then as a very young guy going to these companies, negotiating with them to buy a flow cytometer, was quite an experience. And even now, by doing this, I have the best relationship with these flow cytometry companies, and I think we're one of the best customers here in Benelux. We always get the newest machines. We beta test their machines, and this really started because I was this unexperienced kid, coming there asking questions. But the cool thing is, because there was nobody in that lab, I was actually, as a medic, doing flow cytometry sorting. I had to learn it, went to the courses when we bought the machine. So I was actually a flow operator also at that time, and then gradually became better at it. And then I went to Australia for 6 months to go to, at that time, it was like the Valhalla of flow cytometry. So I went to Sydney for 6 months. And then I really picked up like a very cool technique, that nobody could do here in Europe. And that was really the beginning of my career, that I started making breakthroughs because I had learned flow cytometry really well, and then like a unique technique that nobody knew, and I applied it to the immunology of asthma. And that's actually what kicked it off. But it was coming from a totally naive, unexperienced, as a medic, you actually don't know how to hold a pipette. It's often a joke. But it is really true. Most medics have never seen a pipette.
Right.
And then you're thrown in a lab. But I still hire a lot of medics. I actually love that trajectory, that they are trained in, to recognize disease, to treat patients. And then they come completely naive into a lab. But it's amazing how quickly they pick it up. And I have a theory about this. It's, when you're a medic and you're on your rotations, the final year of your medical training is doing rotations. Every month you go to a different department. Each time you start zero, the lowest thing on the ladder.
Right, yeah.
So within a month you have to work your way up in a group. It's always like that. You come on a ward, nobody knows you, the patients don't know you, the nurses don't know you, the colleague doctors don't know you. So within a month, you have to make it, And so they learn to troubleshoot. They learn how to settle their own problems. They fix their own problems. And you also see that when a medic comes into the lab, they solve their own problems. That's something I really like about an MD PhD. If you can get them into doing a full-blown PhD, not just an MD PhD program during training, but actually spending 4 years in a lab, they're the best PhD students. I'm not saying my other PhD students are bad.
No, of course. We wouldn't say that. I think that's interesting, though. Like, you're kind of advocating for more people that do sort of what you do, and I'm curious because it seems that, in one sense, you put someone in that naive situation, they're maybe better able to think outside the box, see things that maybe people who are trained in that. But I also wonder, how does it flow both ways in terms of, like, do you see things in the lab and then you realize, oh yes, this could help me with my patients? Not even talking about that long road of drug discovery, but just little fundamental insights. But then also the other way, you see something in the clinic and you're like, I need to look at that in the lab.
All the time.
Yeah.
All the time. And this is the advantage of having a basic science lab and infrastructure and seeing patients and knowing colleagues, because that's the big advantage. If you're still an active physician, you actually know the other colleagues in the hospital. There's literally tens of examples per year, where we see something in the clinic and then we take that material, to the lab, try to figure out what's happening, and vice versa. We see something in mice and we rapidly validate when we see it in patients. So this is happening all the time, and this is also fun. This is the fun part of being a physician scientist, that you can, make that bridge very quickly, but you actually have to have, there's a lot of physician scientists who are in clinics, and they mainly do clinical trials. They don't have access to a basic science lab. But, since I have my VIB lab, and even the whole institute, I know which colleague could help a doctor. So I know like hundreds of doctors, but I also have hundreds of basic science colleagues, and I can put those two together, and then I don't have to hear anything about it afterwards, but it's fun to do that, to make those connections.
Facilitate the networking. Yeah.
So VIB has this Grand Challenge program, which is a program that's really meant to take, the VIB, let's say the whole portfolio of science, to application. So in the case that we're using it, it's a collaboration with doctors in the hospital in Ghent and in Leuven and Antwerp, where they see patients with primary immunodeficiency. So primary immunodeficiencies, these are kids who are born, with an absent immune system or part of the immune system not functioning. Big problems because, these kids get, infection the first year of life. They can die the first year of life. They often get nasty diseases like encephalitis, where they turn deaf or blind. So the doctors taking care of those patients, they were always, trying to figure out what is wrong with these kids. And my best colleague here in the hospital is Philomene Haring. She's a real specialist, so she gets all kinds of referrals of different difficult cases. So with VIB Grand Challenges, we've given her money to actually, sort out what is the mutation, and then her lab, gets funding to do that. But as soon as there's something where VIB could help them, being structural biology, we bring in Savas Savides, who's a structural biologist. Bioinformatics, we can bring in cellular assays, even mouse model. We've created mice carrying mutations in kids that were seen in the clinic. Just to understand, what is wrong in this family. We mimic it in the mouse or in an organoid system, and then that goes back to the clinic. And what's very rewarding is we've been able to actually change therapies in those families because we tested in basic science and in mouse models what was actually happening. That's super rewarding for translational science if you can actually help families.
Yeah.
Another outcome of that program is that we're now systematically screening in Belgium for primary immunodeficiency. So every kid at birth gets we call it a heel prick. It's like you take a sample of blood. Well, part of that is now screening for primary immunodeficiencies, and that was through VIB Grand Challenge program. That's very nice to be able to do that.
Mm-hmm. So I want to kind of stick again with this theme of straddling these two worlds. But so my PhD, I studied parasites, which are, universally known as really gross, right? Yeah, so you have this, I think there's this tension when you're studying diseases and, the immune system and, the vulnerability of the human body. But you have these things, whether it's disease, parasite, whatever, it's scary, it's nasty. You see the consequences of it in the clinic. But it also is this really fascinating, challenge or puzzle or just even sometimes awe-inspiring. Sometimes these gross little worms can do like the most amazing things. But do you kind of feel that push and pull, and are both of sides of that motivation for you, like wanting to find the cure for the patient, but also because this is just like, what a fascinating puzzle? Absolutely.
And that's really the heart of being a scientist, right? Is being fascinated, being like almost emotional when you discover something, right? I mean, I was in a PhD thesis defense yesterday where the supervisor was doing like, the talk afterwards, congratulating the candidate. And she said, I will never forget the moment, where you made your discovery, on these cells that were accumulating in your knockout mouse. He literally came down running from behind the microscope, into her office, the middle of a meeting, saying, look what I found. And I had a couple of those moments in my career, where you can really be almost emotional because this is going to make a difference. That this is a discovery. These are very rare moments in your career, but when you have them, this is what's driving basic science. This is what's driving motivation. I think the intrinsic beauty of discovery. I think that is it's also being creative, right? I mean, if you're a scientist, you have to be creative, and that's what I like in basic science. in the clinic, you also have to be creative, but it's always within the limits of, what is allowed, what is reimbursed, what is tolerable for a patient, It's much more confined, My creative, energy, I would say, I use it, in my basic science. I don't use it much in my medical profession, and I use it in my hobbies. That's where I can be creative. But it's very important to realize that being a scientist, it's not this dull, endless peeking behind the microscope. It can be very, very much fun also again, yesterday at this thesis defense, they show all these slides and overview of the PhD. You can also travel a lot when you're a scientist, right? Going to meetings, meeting other people, talking with other scientists, it's really part of the experience of being a scientist, and that's something that medics don't have. Medics also go to medical meetings, but this is like they're taken there in a bus, with 50 other, often local colleagues.
Yeah.
They go for a good dinner, a good lunch. They go to the meeting, but they mainly hear about what's being said to them. They often don't present a poster.
Right.
This interaction that we basic scientists have at meetings, this is something that they're completely missing out. I wouldn't miss it for anything in the world, actually. It's very important to do.
Yeah, I think that's one of the stereotypes of scientists, right, is that they're like antisocial, just in the lab, but you go to a scientific meeting, and when you're involved in those conversations, or you witness those conversations where ideas start flying, you're sharing your work, and you're saying, oh, well, that could maybe, work with what I'm doing, stuff, like the joy on people's faces, and the excitement that everyone gets. It's like, it's actually very social. Yeah.
I think it's key to being a good scientist is being able to communicate, make connections, find a colleague that can help you, or you can help them, It's key. I think you can't be a scientist anymore, by just being on yourself and isolated, and these social skills are very, very important.
Mm-hmm. So just before we finish, we have a question that we ask all the guests here, and that is, if you were to meet an omniscient being, what's the one question you would ask?
What keeps you going?
Oh, flip it on them, yeah. I like that. Do you think from like a physical sense or an emotional sense?
Yeah, how do you manage everything? How do you keep everything in the air? How do you combine things? How do you make choices?
Yeah, fascinating. I never even thought of that, of the idea of like the all-powerful with a agenda being, well, I got to keep this ball spinning, and but it makes sense. Interesting. We could go on for hours, I think. I'm really enjoying the conversation, but I think we got to wrap it up here. So thank you so much for your insights. Thanks for sharing your stories. It was a pleasure to speak with you.
No, likewise.
If you want to hear more inspiring stories from our VIB scientists, be sure to subscribe to Called to Science. And if you like this episode, leave us a like or a review. It really helps. Thanks for listening.